S. Chan presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Have you ever wondered what is the physical relevance of scalar and vector quantities in the real life applications? In this class, we will be learning the same topic. Welcome to S. Chand Academy, and I am Anmol Bhatia. In this class, we will be learning about the course which is Engineering Mechanics, and the topic for today will be Module 1, which is related to transformations or rotations of scalar and vector quantities. For detailed conceptual clarity, you can refer to this book by S. Chand Publishing. The link of the book is there in the description box below. The module that we are starting in this class is module number 1, consisting of these topics. The first topic includes transformations of scalar and vectors under rotational transformations. Then we have a topic which is forces in nature, Newton's law of motion and how it is relevant in particle motion. Then there is a condition of form invariance of Newton's second law, and we will be learning certain problems which are based on friction in this module. So, the first thing or the first topic for this class will be transformation of scalars and vectors under rotation transformation. But before learning this, let us first understand what do you mean by a scalar quantity and what do you mean by a vector quantity. So, a scalar quantity is that particular quantity which is completely described by a magnitude or a numerical value. Let us say we have a case of distance. Distance is a scalar quantity which is particularly described by a magnitude or a value. Let us consider a plane which is this xy plane. In xy plane, the body is, let us say, moving at a distance of 500 meters. So, distance is termed as the scalar quantity. Then the question comes that if we rotate the plane, then what will happen to that scalar quantity? In the previous case, you have seen that the xy plane was perpendicularly aligned with each other. Now, in this case, the xy plane are already aligned perpendicularly with each other, but this plane is rotated. So, if this plane is rotated, then nothing will happen. This 500 will remain 500 in the x direction only. So, this quantity is completely described by only the numerical value and not described by the direction. So, nothing will happen to this scalar quantity change. Then coming to a situation which is called as a vector quantity. So, vector quantity is that particular quantity which is represented by a magnitude as well as the direction. So, let us say in this particular case we have two particular distances. XY plane is there and we have a value which is 12 meter on x axis and we have a value which is 5 meter on y axis. That means a body is moving 12 meter towards x axis and then after that it moves 5 meter towards the y axis. So, if I want to calculate the total distance travelled by the body, that total distance will be 17, and how that value is 17, I will add the two distances together, I will get this 17 value. But if I want to find out the shortest path, then for that what will happen, I need to join both these positions by a straight line, and that will give me a value which is 13 meter. And in order to get this value, I need to use Pythagoras theorem that states that hypotenuse square equals to perpendicular square plus the base square. So, if I put in the value which is 12 square plus 5 square, I will get this 144 plus 25, I will get 169 which is root over. So, I will get this value as 13 meter. This is the concept behind the displacement value. So, I will get this displacement value, and this displacement value indicates a term which is a vector quantity. Why this vector quantity? Because this term is related to a direction. So, the minimum or the shortest distance between the final and the initial position is called as the displacement, and it is basically represented by a vector quantity. So, this concept which is behind the scalar and vector quantity, this is a basic concept that is being cleared. Now, the main topic is what will happen if the plane is rotated, which is the main topic under the rotational transformation. So, if I transform the plane, what will happen now? Here the angle of the angle between the initial and the final position is represented by theta here, and theta is no doubt indicated by tan inverse of 5 by 12, which is perpendicular over the base value. Now comes the situation in which it is being rotated. So, as I have told you that the vector is a quantity that is having both the direction as well as the magnitude. Now, I have the same particular case in which I have this value which is 12 on the horizontal direction, and I have this value which is, let us say, 5 on the vertical direction. Now, what will happen to this if I rotate the plane? So, here this distance which is OB is indicated by x. So, I have marked this distance as x, and from B to y dash, this indicates another distance which is the vertical distance, and it is indicated by, let us say, a y quantity. So, this is y, this is indicative of y. Then again you have to rotate, or you have to transform this plane up to a certain angle. So, after transforming, this OX will be transformed to OX dash as indicated by the figure, and this OY will be transformed to OY dash, and the angle between OX dash and the OY dash value is 90 degree. Now, in order to derive that particular case for this transformations of scalars and vectors, what I need to do? I need to mark the distance which is parallel to this auxiliary plane, parallel to this plane. So, here in the previous diagram you have seen that I had this distance as, let us say, a value of y. Now, from here I need to draw a perpendicular which is parallel to this OY dash value. So, this y value, if I draw a perpendicular from this y dash, and I will draw a line which is parallel to this surface, I will get this magnitude which is y dash, which is the same magnitude as that of the magnitude which is there on the auxiliary plane. Now, from there I need to draw a line which is perpendicular to this axis. So, why do I need to draw the line? Because I need to derive an expression. I want to derive an expression between the two quantities, which is how they are dependent on the condition when I rotate the particular angle. So, here what happens? I need to club, or I need to produce this line so that it meets the base at a point B. And considering the angles, this angle, if I consider it as theta, so as per the simple geometry, this angle would also be treated as theta. So, what happens here? I have certain distances which are x distances and certain distances which are x dash distances. So, which distance is x and which distance is x dash? Let us first clarify that. So, the distance from O to B, which is the initial distance, is marked as x, and this plane is rotated to OX dash. So, the distance from O to this value is marked as the distance x dash. So, this distance is x dash, this distance is x. Then you have this auxiliary plane which is this rotated plane, this distance, and this value is having the distance of y dash, which is indicative of the rotational values of x and y. Now, the thing is to derive the relationship. In order to derive the relationship, I have drawn a perpendicular from the surface which is A, I have drawn another perpendicular from the surface just to have clarity on how these angles are indicated on the surface. So, let us again repeat the same, which is this distance. X dash distance is the distance which is there on the horizontal axis, and y dash distance is the distance which is there on the vertical axis, but these two planes are the rotational planes, and angle is these two angles, which is the indicative of the angle between the two horizontal and the vertical plane values. We will stop here for a short break. Till now we have studied about scalars and vectors and started a concept of rotational transformation. When we come back after the break, we will study more into the detail about how this expression is derived.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. So, before going to the break, we have studied about the angles and the markings which are there on the surface of the rotational transformation. We are learning about the scalars and vectors and how the relationship is transformed, that we will be learning in this topic. So, before going to the break, we have learnt about the markings which are there on the surface. So, markings are x dash, y dash and theta. Now, the main idea is to derive a relationship between x dash and x. How these x values and x dash values, how this y value and y dash value is having a relationship amongst each other. In order to derive this relationship, as I have told you that we have this particular distance which is OB dash, this distance is x dash. Now, if I break that into two sections, I will get this OC dash value which is this value and C dash B dash value which is this value. So, this entire x dash is broken up into two segments. Now, the first segment which is OC dash is this segment is the cosine of this x value. So, you can say that the horizontal component of this OC, this x is OC dash. So, in place of OC dash, I have written x cos theta. Now, C dash B dash is defined as the sum of C dash D plus DB dash. So, C dash D plus DB dash. So, it is again broken up into two segments, which is this segment which is C dash D and another segment which is DB dash. Now, in the next step, I need to get the relationship between DB dash and CD. So, I need to get that value. So, how do I obtain that value? Let us understand. So, as I have told you that x dash is broken up into two segments which were OC dash and C dash B dash, and OC dash I have told you that it is represented as the cos component of x or the horizontal component of this x value which is x cos theta, and this point we have named as D. So, I have broken up into two segments, broken this segment into two segments which is C dash D and DB dash. Now, what is the main idea? The main idea is to get a relationship between x, y and theta values. So, what happens here, C dash D, if you observe this plane is dB sin theta. This value is the sine component of dB. So, in place of this I can write that dB sin theta, and in place of dB dash, which is this value is the sine component of AD. So, AD sin theta is the value. Now, in this step what will happen, I will keep this x cos theta as it is, and I can take this sin theta as common from both the terms. I will get dB plus AD. Okay. So, x cos theta is already there in terms of x and theta values. Now what is left? I need to have certain quantity which is the sum of dB and AD. So if I add this value, which is this value dB and AD, I will get this total term, and this total term is what? Y. I have taken this dB and AD inside the bracket, and I have taken this sin theta common, and when this dB and AD gets added up, I will get a value which is y. So the relationship for x dash comes out to be x cos theta plus y sin theta. This is for the transformation case. Now if you have let us say if you have a plane which is having a distance of x on the horizontal direction, and it is having a distance of y on the vertical direction, and that plane is rotated by an angle of theta, and you want to find out what is x dash value and what is the y dash value. So for that, x dash is x cos theta plus y sin theta. You can transform or calculate by putting in the values inside this expression. Now let us come to the y dash expression. Now in order to find out the y dash expression, let us look at the diagram again. So in the diagram I have told you that this distance is the x distance and this distance is the y distance, which is the vertical distance. Now what we have done, we have rotated this plane at a certain angle. So this x dash and y dash is denoted by the dashed lines. That means this is the rotational transformation. Now what happened, x dash value is this value and y dash value is this value, which is the parallel value of or the parallel line from this axis. So this indicates the y dash value. Now the thing is to find out the relationship between y dash and y. So for that, what happens, I need to calculate one thing, which is I need to mark or I need to extend this y dash value to a certain extent. Like if I refer to the previous diagram, it had this y dash value only, and I have increased this distance so that a relationship comes. So this distance is increased and a line is made so that a complete box is created. Now what happens, the theta part is there, theta is this indicative, theta is just indicative of the angle which is there on the surface, and from there what we can conclude that y cos theta is this component that we have of y. So if this distance is y and it is having an angle theta, so this component would be y cos theta, and similarly if this is theta and the distance is y, so this component would be y sin theta. Okay. So y cos theta minus this y sin theta component will give me this component which was required. So y dash is y cos theta minus x cos theta component. So we have two different components. One component is this component, which is x sin theta component, okay, and another component is y cos theta component. So y cos theta minus x cos theta component will give me this y dash value. So y dash value is this value, which is y cos theta minus x sin theta. So overall, if I look at the equation x dash and y dash, if I look at the equation of x dash was x cos theta plus y sin theta, and y dash is the negative of sin theta minus x sin theta is there. So it has minus x sin theta initially and then plus y cos theta. This is the main formula to remember. So in this derivation, what we did, we had calculated or we have derived a relationship amongst x dash and y dash. So x dash is the transformed horizontal distance, y dash is the transformed vertical distance. So transformed horizontal distance is having the relationship that I have told you, and y dash is having the relationship which is this value. Now what happens, we have this plane, let us say we have OX as the horizontal value and OY is the vertical value or the vertical axis. Now this plane is rotated by an angle of theta. So transformed distances are ox dash and oy dash. Let's say I have a plane which is A, or let's say I have a vector which is A vector which is there on the surface, and I need to find out what is ax dash and what is ay dash. So for that, as we have derived the relationship which is x cos theta plus y sin theta. So x is ax cos theta plus ay sin theta, that means the x component of A cos theta plus ay sin theta. And similarly, if I want to find out what is ay dash, so relationship, in order to remember that relationship, what happens, minus ax sin theta plus ay cos theta. So this is the main idea behind the rotational transformation of scalars and vectors. The second thing is when I talk about another plane which is yz plane. Till now we have talked about xy plane. So for xy plane the values are clear so far. Now for the yz plane, we consider this axis as y axis and this axis as z axis. Now if I transform it or if I rotate it by an angle of theta, what do I get? I will get this oy dash and oz dash, and on the surface I have a vector which is A vector. So if I want to find out what is ay dash value and az dash value, so ay dash or az dash will be equal to the first component which is the horizontal component which is ay cos theta plus the vertical component which is az sin theta. And for this dash part, I need to have this component with the negative 1 initially and then this component with a positive 1. So ay sin theta plus az cos theta, this is having a negative sign. Then you have the third case or the third plane which is the zx plane. So for zx plane, you have to take this axis, horizontal axis as z axis, and then another axis is x axis. So you have a zx plane. Now if I rotate this zx plane at an angle of theta, what do I get? I will get this oz dash and ox dash, and I have a vector on the surface which is A vector. So I need to find out what is the transformed values or transformed components of these two. So az dash and ax dash are the two particular things that I am interested to find out. So for that, the horizontal component cos theta plus the vertical component sin theta. So horizontal part is az and the vertical part is ay. So az cos theta plus ay sin theta, and similarly as per the formula that we have derived, this is the negative sin theta plus ay cos theta. So this is so far the concept behind transformations of scalars and vectors. We come to the end of this lecture. In this lecture, we have learnt about scalars and vector quantities, and we have derived a relationship for the rotational transformations. For detailed conceptual clarity, you can refer to this book by S. Chand Publishing. The link of the book is there in the description box below. If you find the video interesting, like, share, subscribe the channel and hit the bell icon for future updates. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.